It's in the book. I don't know which one it is. Okay, so here's our practice. It has two sides.
It's a practice. It's a practice. Sport. Let's sport through this.
David is good.
It was due today.
It's in school.
It's on the school.
David is a good. That's really good.
It's outside.
No, it's on school. No, but
Joe says it's not there, but Joe's wrong.
I think Joe's wrong. You put everything there. I think you're wrong.
Cereal production today was not good. So let's remember to bring it either Wednesday or Friday during office hours, okay?
Only office hours.
Only office
What?
hours.
Oh, bringing the cereal stuff.
I only did because
Please, don't forget. Looks like I'm missing Caitlin and Jaden
He's here.
I'm gonna do that Wednesday.
and London.
Mailman.
Over here.
Hey. Jack. You can do it. Oh, don't put it That's the context.
Yeah, I knew that was gonna happen.
I knew that was gonna happen.
Hey, have you started the first problem yet?
David is good.
It could have been.
Send Johnny walking by myself.
It's a chicken.
Oh.
Here we go.
It's like.
Find the exact value. Guys, exact value means no calculator. Okay? So we need to be able to do this without a calculator. So, somebody tell me where I start.
180 divided by 6, and then times it by 7.
So this is the sign of 210.
How would you do that? So
210 is not the answer. I need to find the sign. So I need to draw my triangle, remembering my setup. So 210 will be down here. Perpendicular, straight up. And then the key to the whole problem is, find that right there. That angle right there. That's the key.
that is
So, look where it
30
is.
degrees.
30 degrees.
260.
And then we know that across from the 30 is 1. Hypotenuse is 2. Other side is 3. It's a 30, 60, 90 triangle. Anything negative?
Oh, yes.
Yeah.
1, 2, 3, 3.
Oh, 1 and 3.
Are they both negative?
6 to make it positive.
Left, down. Hypotenuse is always positive. We want the sign. The sign is opposite over hypotenuse, negative 1/2. Jake?
Would you use eyes with a -3 so it was like would you like use
There's
it
no
as a
eyes.
-3?
There will not be any eyes.
Oh,
Okay? No eyes.
I can't understand that.
You're not taking the square root of -3. You're taking negative the square root. All right, next, cosine 270. What's special about this one?
You make it a circle.
It's down here, right? 270?
Yeah.
So when you're on the axis, you draw a circle. Radius is 1, which makes this what point? 0, -1. 0, -1. So x is 0, y is -1, and I want cosine. what's cosine?
X over R.
X over R. X over R will be 0 over 1, which is 0. So I change it to degrees.
60.
So it's going to be negative 315. You'll have a baby calculator to do arithmetic if you need it.
So we have a reach.
Now, how do I do negative 315?
The other way.
Other way. So if I go the other way, this is negative 90, negative 180, negative 270, negative 360. Remember, this axis is double duty. It's where I start and where I ultimately end. So negative 315 is going to be right here. Perpendicular, straight down. So I need the angle between 315 and 360, which is 45. So the sides are 1, 1, root 2. What's negative? Nothing. Nothing's negative. Why? I'm in quadrant 1. I need the tangent. The tangent is opposite over adjacent. So the answer is 1. Find the smallest positive and negative coterminal angles for 119 pi over 5. Now, there are a couple of different ways, like always, that you can do this problem. I want you to think about this for a minute. Well, first of all, how do we find coterminal angles? We add or subtract revolutions. So in radians, I would be adding or subtracting 2 pi. In degrees, I would be adding or subtracting 360. Now, that's a lot. Would you agree with me? That's a big number. So I'm going to go ahead and figure out how big it is. So this is only one option. I got 23 4/5. Did you get that? Did I divide right? I think so. Hope so. Now tell me about 23 4/5 pi. Tell me about that. Is it more than once around?
Yes, it goes around 11 times.
It goes around 11 times. How's come it goes around 11 times? Because every loop is 2 pi's. Right? So in 11 loops, it would be 22 pi's. So spin, 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 spin. Throw all that out. This is really 1 4/5 pi. Or 9/5 pi.
Wait till explain.
If you change that into degrees, you will do the same thing, only you'll be getting rid of 360s. I'm getting rid of 2 pi's, because 2 pi doesn't change my position. It just spins me around. So this is really the angle I'm looking at, and this is the smallest positive angle. Right there it is. Essentially, you guys, how did I get rid of it? I took out 11 2 pi's. Now, if I take out one more 2 pi, I'll go negative. Would you agree with me if I subtract 2 pi from here? 2 pi is 10/5. This is my smallest negative. To find coterminal angles, you just add and subtract, in this case 2 pi's. I chose not to start subtracting 2 pi, because I would have had to do it 11 times. Instead, I just said, hey, I'm gonna get rid of those extra revolutions and just look at the angle that matters, which is the leftover part. Find the length, okay, this one needs a calculator. Find the length of a shadow of a 32-foot pole if the angle of elevation is 28 degrees. The starred problems require calculators.
So that is inches.
So, first of all, I kind of just drew it up here. Does that picture make sense to everybody? Pole standing up, shadows on the ground, angles 28. Somebody said it's tangent. Tangent 28 equals 32 over x. Don't be messing up this equation. Multiply by x and divide by tan 28. There are no points for skipping steps. So if you want to skip steps, it's fine, but don't mess it up. Make sure your calculator's in degrees, by the way, because that's a degree measure. So 32 divided by tangent 28. I got 60.18 feet.
Okay.
Anybody else get that? Good? All right. Now we got a real turning problem. So start with what you know. 510 revolutions per minute. That's what I know. And ultimately, after who knows how many steps, I want to end up in miles per hour. Remember, the key to doing this problem is to remember that a revolution is a circumference, which for this problem is 2 pi, 10, 20 pi inches. Yeah. That's the key. The rest of it's easy. You have to remember that a revolution is a circumference. All right, so what am I doing now? 60, actually at 1 hour.
You want an hour?
Yeah, so
60 minutes.
60 minutes in 1 hour. And then I have inches. So 1 foot, 12 inches.
Yeah.
And then 1 mile, 5,280 feet. So minutes, revolutions, feet, inches. Looks like I got it.
I think so.
So I'm gonna type it in. So 510. Don't forget the pi. I think some of you forgot that last time. Times 60 divided by 12 divided by 5,780. Remember, everything in the bottom is getting divided by. So you should get 30.34 miles per hour. All right, here we go. No calculator. Find the angle whose cosine is √3/2. Jake?
You with the cosine, so it would be opposite over. Oh, adjacent over hypotenuse.
So √3/2, so it looks like that. And that angle right there, can you tell how big that is?
30 degrees, 30
So
degrees.
it's 30 degrees, but I need that to be in radians, so just
I
stop.
know what it is.
30 is what fraction of 180?
Pi over 6.
Pi over 6. So pi over 6.
Same.
Money bag.
Inch, no.
Except we're not done.
What?
We're not done.
What? Not done.
There is another triangle that I could draw.
Oh, bottom
Not bottom left.
Wait.
Bottom
Third.
right.
Bottom right.
Because, let me redraw it. Wouldn't this still be root 3 over 2?
Yeah.
Wouldn't that still have the right cosine?
Wouldn't it
And
be-
this is still the right angle, it's still 30 or pi over 6. But the answer
It's both.
is that. How big will that be? Can you figure it out?
330?
Well, that would be the degree measure.
Oh.
So you could do it in degrees and then change it to radians. Can you figure out, could you figure out the radian measure? What's all the way around in radians?
360. Oh, 2 pi.
2 pi. So wouldn't this just be 2 pi
11.
minus pi over 6?
11 pi over.
11 pi over 6, that's exactly right.
Sorry. Yeah, I care. But people are okay with that.
How's come there's 2 answers to that problem? Because cosine is x, x over r, x, and there's 2 places in the coordinate plane where x is positive. Right? All right, I've drawn this one for you.
Ms. Ford,
Yep,
would you want both answers?
absolutely.
Oh, we have to put pi over 6 and 11 pi over 6.
You need both of them.
Yeah.
Oh.
You need both of them.
Need pi over 6.
All right, I've drawn this picture for you, so you're good to go. Sine is 4/5. What does that mean? Opposite over hypotenuse is 4/5. What do we need to do?
Pythagorean theorem.
Pythagorean theorem to find the missing side.
9.
So it looks like the missing side is,
4. Wait, it's not, yeah. I'm 16.
thinking in my head, which is a bad move. 3,
Great.
and I want tangent.
4 over 3.
Tangent 4/3.
Nice.
Okay, next, find the arc length.
Arc
Do
radians.
you remember anything about arc length?
Radians times radius equals arc.
Okay,
Yep.
so arc length is radius times radians. And we know the radius is 5, but we have a problem because the central angle is in degrees.
Yeah.
And it needs to be in radians.
So pi over 180.
Okay, so you can absolutely, the way that will never fail you, ever, ever,
2 pi over.
you can do pi over 180 equals something over, what was it, 120?
Yep.
I would go ahead and reduce that since you're gonna have to do some stuff with it. So I think that's 2 pi over 3.
That's 5.
Times 5 over 1. 10 pi over 3. Now, again, I'm trying to encourage you to kind of think here a minute. Think about 60 degrees. 60. 60 is a third pi, isn't it?
Yeah.
So does it make sense that 120 is 2/3 pi? Because it's 2 60s? All right, calculator time. Here we go. How do we find cosecant?
1 over 6.
1 divided by sine.
Yeah.
128 second angle degrees. 19 second angle minutes. And then the fun one, 32 alpha plus. I got 1.2747. No, there's no unit on that.
Oh.
That's a secant, so it's a
Oh.
ratio, just this, yeah. That's not an angle. It's on this, the cosecant. Everybody get that?
Yep.
Perfect. And number 9, find the angle of depression of a squirrel looking at a nut on the ground. Alright, so here's the squirrel looking at the nut. Here's my angle I'm looking for. Remember, your angles of elevation and depression are always right there. He is in the top of a tree, 19.5 feet tall, or meters tall, and the nut is 103.2 meters from the base of the tree. So where do I put the 103.2? On the bottom. This is the base of the tree. Alright, so what? Sine, cosine, or tangent?
Inverse tan. Or tan.
I'm going to do tangent, so tan x equals 19.5 over 103.2. But this is one of the tricky ones. Don't do any math. Don't do any multiplying or anything like that. X is going to be the angle whose tangent is this. So you just type second tangent that fraction. And I got 10.70 basically, 10.7 degrees, is that what you got? We good? All right, I'm gonna hand back some papers now. While I'm handing them out, I want you to get your notes out. And I want to see what you can remember about graphing. So we are ready for this problem, which is a doozy. But using your notes, let's see what you can remember. Okay? And I'm gonna hand back a whole bunch of papers so we can answer questions about it as I get them all passed back. Here comes some quizzes. You can look at, go over, after I get them all passed back.
Oh, it's 180. Oh my god. I did pi over 360 instead of pi over 180. That's the only thing I had that on. I don't know.
And no one like transferred it. I saw mine.
Oh, did you not change your
We should none of these is
Guys, are you graphing this thing?
I am so dumb. I should have done, okay, that was the dumbest mistake ever.
I knew that you had to. Oh, you got something wrong. Wait, who has that?
She's
Who has
bad
that?
at that one. Joe.
No, you don't have that one. Where's your quick? Then you have to say quick. Hey, quick.
Wait.
Almost done. I want to see some progress on this graph, guys.
I don't think I got that.
I got literally every single one of these.
All right, so we'll take questions in a second. First, I want to get this graph done. All right. So, what do we remember? Nothing, that's trouble.
Negative 1 and 1.
Well, it would be negative 1 and
Oh,
1, but there's a
2/3.
two-thirds
2/3 and
included.
1. Okay.
So that's gonna be my amplitude. And normally, I know that a cosine under normal circumstances, a cosine starts here and does this, right? That's what a cosine does? But this one has a horizontal shift, so it's going to go left pi over 6. So that means that instead of starting right here, which is where we normally start, it's starting right there. Now, it's gonna look exactly the same. It starts at the top of the hill, it ends at the top of the hill. So here's, okay? Now, I'd really like to know where it ends. In order to know where it ends, I have to know what its period is. And its period is going to be 2 pi normally, but it's been divided by that number.
So 6 pi, 3 pi.
So it's 2 pi divided by 2/3, which is 2 pi times 3/2,
So 3 pi.
which is 3 pi.
Yeah.
Now, do not label this 3 pi.
Say.
That would be 3 pi if I started at 0, but I didn't. I started at negative pi over 6, and I'm adding on 3 pi. So negative 1/6, remember you can forget the pi's if you need to. Negative 1/6 plus 18/6,
Yes.
17 pi over 6. So wherever you start, you're gonna add your period on. That's how far you're gonna go. Well, then it's 0 plus, so anyway you do that, yeah. If you're at 0, you're not really gonna think about it. So negative 1/6 plus 18/6. Now, what's right in the middle?
8 pi.
Well, I don't know. What's negative 1
Plus 17.
plus 17?
18. 16, 16, 16.
That would be 16/6. But I have to take half of it,
Oh,
and we average. So what is that?
86.
Actually, you know what?
16,
I don't even
12.
care. If you wanna leave it as 16 pi over 12, that's fine. There is
Really?
so much arithmetic with some of these that I'm okay with that. Or if you wanna break it down, you
4/3.
can. That would be
Or
8/6. Might be easiest to leave it that way. It's also 4/3. But remember, how are you gonna find this? You're gonna average these two. So 8 and 17 is 25. And you're taking half of it? So 25 twelfths? Negative 1 and 8 is 7 6. So that one's gonna be 7 twelfths. No, negative 1 and 8. Yeah, negative 1 and 8 is 7 6.
You're confusing yourself.
Too much stuff going on.
That's a lot. That's why the top sucks.
All right, let's pause there. We got more graphing to do. Actually, we're gonna go backwards. We're gonna write equations from the graphs. But first, what questions did you have about your paper, real quick? I need to have it.
6B.
6B says find the cotangent of 3. How do I type that in on my calculator?
1/10.
But is there a degree mark on
Yeah,
there?
you were in degrees.
Oh, so I have it in radians.
That's what you got.
1 divided by tan 3. But my calculator has to be set in radians.
Did you count off of that?
I did get the wrong answer. Yeah, I do. You gotta have the right answer.
I don't know if you counted off the D.
And I probably messed up on somebody's. I don't know.
No, you counted me off. Don't worry about it.
That's why you asked, because it's marked wrong.
Exactly.
All right. Who else has a question? Anybody else have a question?
I had improved.
I think Aiden might have a question.
Oh, right.
All right. We have a hawk sitting.
You're wrong. You have a lot of questions. Oh, you got lucky. Oh.
Tree is 23.
Completely wrong there.
Mouse on the ground. Angle of elevation is 19. How far, here's the hawk. How far is the hawk from the mouse? Here's the hawk, here's the mouse, that's X. So which function do I want? Sine, cosine, or tangent?
We're gonna go side.
Sine. It says opposite over hypotenuse. So then I'll bring the X over. And divide. So I gotta make sure I'm back in degrees now. I'm just gonna type that in on my calculator. Make sure you're in degrees.
Oh, wait, we're not done.
We good? All right, then let's take a look at our notes. 2A.
I already got 17.
Don't worry, folks. The bell will ring when it rings. You'll be okay. And you still have 2 periods to go.
Tell me about it.
We're starting at 5 or 6. I'm 5 or 6.
Wait, are they?
So this is a song.
Stand up, stand up.
All right,
It literally takes the picture.
here we go. We are going to write a sine equation and a cosine equation for this curve. All right, so we're going to start with the easy one. Doesn't it look like sine? So we're going to draw it right that equation. Now, when you write your equation, you could have a number in the front.
Starts at 150.
You could have a number on X. You could have a number added or subtracted here and added or subtracted here. So when you write your own equation, there are 4 things that you have to pay attention to. This is the height of the curve. Well, that's easy. Our curve is 1/5, so that's my amplitude, 1/5. This is easy because that is my vertical shift. Does it look like this picture has been lifted up or down at all? Nope, so that's a 0. or you can leave it off if you want. This is easy
Oh, that's,
because my picture has shifted pi over 6 to the right. So that's a minus. If it had started over here, that would be a plus, right? But it's a minus. Now, this number right here is always the tricky one, and it doesn't need to be. We know that our period is 2 pi divided by this number. I'm going to call it b. That's not a 6. So that's 2 pi divided by b. To find the period, think about what we just did a minute ago when we graphed. To find the period, we took 2b and divided it by the coefficient on x. Okay? Now, what is my period? How far is it from start to finish?
5.
4.
4 pi over 6?
Yeah.
Isn't that 4 pi over 6?
Yeah.
So 4 pi over 6 equals 2 pi divided by that number. So I'm going to cross multiply. 4 pi b equals 12 pi. I'm going to divide by 4 pi. And what is my missing number? 3. No. This missing number, b, look, b equals
3.
no, 3.
Just 3.
The pi's cancel.
Are we sure?
3. Okay? Now, here's the good news. I now am going to write a cosine equation. The only thing that's going to change in the cosine equation is this guy right here. This is still going to be 1/5. This is still going to be 3. And that's still going to be 0. Because when I think of this as a cosine, I am simply thinking of a different chunk of the curve. Isn't that a cosine?
Yeah.
So it's still the same height, still the same length, still the same everything, except now where am I starting?
2 pi 6.
At 2 pi over 6. So x minus, I'm going to make it pi over 3, 2 6. Now I am starting here to look at it. Does that make sense to you?
Yep.
So once you have done the work with your first curve, the second one's a no-brainer. All right, I'm going to stop there. And we'll pick up here tomorrow. My guess is that tomorrow we'll finish 4-4 after our quiz. And then we will move on. He asked questions. Because across from here, it's 6.